Our topic is solving quadratic trinomial equations by factoring. We chose this topic because of the importance of basic multiplication skills and number sense and understanding factors and distributive property. The skills required to factor quadratics are constantly used throughout all high school math classes, including calculus.
All right, so we based our a lot of our research on how we answered questions off three major articles. The first one was solving quadratics with one unknown, which focused on both use solving quadratic equations with symbolically and with word problems. We focused on symbolic notions of it and kind of figure out where the students were based on basically students having problems with solving various different types of quadratic equations. So what we found out through this for the research is that number one, how the teacher presents a topic, whether it's focusing on just manipulating equations or focus on what the equations actually mean, is one way that basically determines or helps students learn a little better on it. The second thing we noticed on this was that a lot of the errors in terms of factoring were either numeric or if the problems deviated whatsoever from their procedural fluency, it causes students to have a little bit of confusion with that. The second article, which is an NCTM article, was talking about comparing tangent sequences with factoring, and got kind of focused on looking through the patterns on tangent sequences to teach factoring equations. This one here, it was cool to kind of see how you can make the connections between factoring, something that's been used in different contexts, and how you can make that connection to factoring quadratics. The third one article, which is from another education journal, was talking about asking questions, and this is kind of how we formulated the way we're going to ask questions in case where students had issues basically had issues kind of getting one of the first steps. And it's basically the importance of guiding questions is that the more the teacher asks students guiding questions and allow the students to draw their own conclusions, the more likely they're able to grasp concepts and help them basically overcome obstacles. So the combination of these three articles plus a few other minor ones is kind of where we formulated sort of the idea of what type of questions we're going to ask in terms of quadratics, how we were going to progress them, and also what we're focusing on in terms of seeing misconceptions with procedural fluency, misconceptions recognizing patterns through various contexts. All right. So the student here actually factored the question really well. He recognized right off the bat that the two factors of 80, 8 and 10 add up to 18. So he was able to set that up perfectly. However, he basically blanked out on what to do afterwards to solve it. I tried to ask him some kind of guiding questions for that, and he still blanked out on it. So what I wanted to do to make sure it was attributed to either misunderstanding on ZPP or zero product property, or whether or not it was just him getting rusty because it's been 3 weeks in school ended. So the response I would do, and actually what I ended up doing was I would ask him, do you remember what the zero product property is? And at that point, he said no, not at all. So what I did was I set up a similar example to it. Basically ask him how to factor it out. We factored it out, and that said equal to 0. And then I asked him from there, do you know what to do the next step from that? And then once you recognize that basically they was set up to equal 0, to kind of light bulb clicked in his head. If you didn't recognize that, I would go the step further to explain what the zero product property was, and then continue working through that as well. So basically, once I demonstrated that problem, I let him go back to the original problem, have him solve it, and then if it was a full-fledged lesson, I would pretty much give him a similar problem to that, just to make sure that he understands that property, because if he doesn't understand that, the other factoring problems are going to be, so numbers 2 through 4 will be problematic for him.
Right. In the second video, the student was treating the quadratic like he would a linear function, so he was moving everything to the right-hand side of the equal sign except for the x squared. He then saw that he wanted to factor the 2 out from the x squared, and then he moved everything back over, and then was able to solve the quadratic. But when he got to the bottom part where it was x minus 1 and x plus 8, it should have been the 7. So when he was asked, he was confusing with the addition and subtraction of the two numbers, and he said that 8 minus 1 is 7, and so that's why you put the 8 there. So again, a follow-up question would probably go along the lines of, showing a distributed property, have him work a distributed property and see how that distributed property worked itself out, and then have him look at that problem again and see if he could figure out what he had done wrong. And again, I would continue in that process until he would see the correct way to factor that problem. When you are ready.
All right, so for the third problem, the student recognizes that he should move everything away from the x squared term. So again, it kind of looks like his initial reaction is to solve like a linear equation where you're moving everything away from the largest x value. All right, after he moves the 12x and the 10 to the right side of the equation, which he actually does properly, then he divides everything by the coefficient in front of the x squared term, which is a 2. I think it is possible in this case he kind of got lucky that all the terms could be divided by 2. I'm not sure he really planned it out that way, but it did work out. And once he got rid of the 2, the leading coefficient, then he moved everything back over and set the equation to 0. So moves the 12, or now it's a 6 and a 5 to the left side. Once he did that, then he could factor the equation. He did factor it correctly, and then solve for x using the zero product property. It looked like he got the correct solutions, but I would probably follow up by asking him why he decided to move everything before he factored out the 2 value, and also if he understands the difference between factoring out the leading coefficient and just dividing to get rid of it. Like, why does it work when you divide everything by 2 and also when you factor it by 2? Like, can you see that he's using the same process here to solve the solution? But I think he understands the problem pretty well, and we can move on to a more difficult problem.
When you are ready.
All right, so for the fourth problem, the student recognizes that he has to factor this quadratic trinomial, and he does create his 2 sets of parentheses, has them set both equal to 0, and then he correctly has the first term in each factor, the 3x and the x, right? But then from there on, he's kind of stuck. He knows he needs to have the second factor, and he's kind of just going through the motions of guessing and checking, but he doesn't have a direct process of how he can factor this. So it seems to be a total lapse, and exactly how do you factor a quadratic trinomial when the a value is greater than 1, and you can't basically... Alright, so when the a value is greater than 1 and you can't eliminate the a value by dividing or factoring out through every term. So there's no GCF in this case, and he's trying to guess and check to get his factors, but he's totally stuck and has no idea what to do. So it seems like in response, I would kind of walk him through the double distribution method or the FOIL method so he can see exactly how that B term is created. So once you can see that it's not just the last 2 numbers that create the B term, it's a combination of the first 2 numbers and the second 2 numbers, which add together to create the middle term. I think you can start seeing like why he couldn't figure out his process using the guess and check method. So we could set him up with a couple of problems where he can double distribute to see how the B term is there, and then reverse by factoring those problems back to the original equation. Then try to give him a simpler problem to do to factor where the a value is not 1. And without him learning the whole new process yet, without learning the slide and divide method, just by guessing and checking, to see if he can actually factor by guessing and checking. Then we're going to have to go through and reteach the method, factor by grouping or slide and divide, so that he can factor these problems every time without relying on the guess and check method.
Cool. What we started with the student, he was coming off of several weeks of working on quadratics and learning them. So we had to start using guided questions, and once he got the hang of it, he quickly caught on to the simple quadratic solving. But the problem came in when he was, as our articles had spoke, the students were having complications when they were just computing the numbers, when they were just doing the arithmetic. They could factor fine, but it was always the computations where they were struggling. And that's what we saw with this student in the second and third problem. And then later on with the fourth problem, when it was a more difficult quadratic to solve, again, he ran into problems. So in forward, we wouldn't actually have to start from the beginning of quadratics. We would just have to reteach the more complicated ones where you have to do the slide and divide or the group factoring. And that's where we would need to focus our instruction for this particular student.